Hello there.
Good evening and welcome everybody, this is Obi-Wan Pez for Nsimplex Pachinko, our standard ad break, startup, whatever, ended up happening faster than expected, so hooray. Thanks for coming on in, everybody, over from Zach's channel. Zach is here to have a conversation this evening about building thinking classrooms.
Hey there.
And here he is. How you doing?
Fine. How are you?
Excellent. Good to see you. Or, well.
Good to hear from you. Yeah, I was going to
Yes.
say, it's good. Do whatever you want to do as far as... You want to just do voice? It's fine with me.
Yep. No, this is good.
Okay.
Do you... have any opening statements?
I don't have any. I actually have no idea what we're planning. That's my opening statement is, what are we planning? What kind of craziness do you have in mind? Because I'm happy to chat about just anything, but
Yeah.
I'm interested in your thoughts here.
The hey, Collar Cone. Sort of. So my idea was to go through anything you might be interested in anybody who hasn't seen it yet. Building Thinking Classrooms by Peter Liljedahl, and talk about theory, talk about what may have stood out to you, anything you've tried before in classrooms or might be interested in trying in classrooms.
Sure.
So I guess from a Doctor of Math Education, right?
Yeah, I mean that is one of the many titles I guess I can go by. And I mean, I have, so for the record, those who are listening to this, I have a PhD in mathematics with a concentration in instructional technology and learning sciences. That's fancy for education, and I can claim some level of expertise in that area. I have worked extensively with Liljedahl's framework, at least enough to know about it and to talk intelligently about it to some degree.
You said
I tried to use some of these ideas in the classroom before, so I guess we'll get to that. But
and at what level?
At what level? So I have used this. It's complicated because when I first introduced to this idea, I had gone to a professional development as a high school teacher, and if I recall, this was 2016 at the Park City Mathematics Institute. So it was a long time ago.
So you got an advanced look at it.
This is before. I think this was actually when he was doing research, if I'm not mistaken.
Yep, it was before the book.
Yeah.
The book I have is copyright 2020.
Yeah, and I have the same one sitting in front of me, so I know what you're talking about. So he gave us the classic taxman problem. I don't know if you've talked about this on stream, but it's one of his favorites.
Yes, briefly. But we might as well go over it. It's been many weeks.
And we might as well talk about it for the benefit of those who haven't seen this problem before. Absolutely. It's a pretty fun problem, and it invites you. Like I think the solution's non-trivial here. It's a very interesting thinking task. And if you try to generalize this problem, the generalization is super interesting. I've never actually fully generalized this problem, and so maybe we can play with that today. I've done some generalizations though, and so let's just talk about what the taxman problem is, because this is how he started his session. and I feel like that's important. If you know Liljedahl, you should know this task.
Yep.
So the idea is this: you're given 30 envelopes with $30 amounts in it, numbered 1 to 30. I guess there's variations here, but
Yeah. No sucker. I was just going for 12.
You're going for 12. Go with 12. I'm used to giving this with larger end, but let's do it with 12. That's great. 12 is great. I don't really the number is less important than the concept here.
True.
So anyway, so you have 12 envelopes numbered 1 through 12, and they have the number of the envelope tells you the dollar amount of the value of the envelope. Okay. So 12 is worth $12, 1 is worth $1, 3 is worth $3, etc., etc. And you get to choose an envelope. And the taxman gets to take envelopes based on your choices. So say you choose the number 3, the taxman will take, or number 4, I think is a good example. If you take the number 4, the taxman is going to take any factors of 4 that are available. Okay? So for instance, so as far as 4 is concerned, the factors of 1 and 2 would become the taxman's. Right?
Yep.
So I'll let you label those. I'm letting you catch up.
Yeah, I'm about 20 seconds ahead of you, so.
That's fine. Okay. So I'm looking at lag here, and I'm just trying to figure out where... I'm watching the stream as I'm talking, and I'm sort of trying to narrate what I'm seeing. It's sort of uncanny, but this works. Anyway, if you want to send me a link to the Excalibur, that might give me I can sync my talking a little better to what you're writing.
Start session copy link to Zach.
Thank you very much.
Yeah.
Much appreciated. You are a gentleman and a scholar.
Well, at least one.
Okay, there we go. So 1, 2, and 4. So you get the number 4. The taxman gets 1 and 2. Great. Now you have to make another choice, and any choice you make, you give the factors that are left over to the taxman. So say I choose number 12, then I choose 12, and then the taxman would normally get 1, 2, 3, and 6. But because only 3 and 6 are left, taxman will take 3 and 6.
And 4.
And 4. And well, yeah, the 4 has also been.
We've already taken it. Yeah.
I forgot that one. Thank you for keeping me honest here. This is good. So this play continues.
Zach, I think I want the number 11 next.
I'm getting there.
Okay.
I was getting there. So the thing here is that if you choose a number that doesn't have any factors available, that's not allowed, and the taxman gets it. Right? So the 11, for instance, would be automatically the taxman's. That's not a legal move. As a matter of fact, the way I've left it, the only legal move left is 10. And so I could only choose 10 now, and the taxman would get 5, and the other envelopes that are left over. So 7, 8, and 9 all go to him. And the goal here is to take your revenue, which would be $26, so that would be your score. The taxman gets everything else, which is, let's do the math here, 6, 5, 11, 17, 24, 32, 41, $53. I sucked there. Remember, kids always pay your taxes, right? This is the way. Okay, so the question is, after I explain all this, and Liljedahl does a masterful job of simplifying this a bit. How can you beat the taxman? Right? Can you beat the taxman? And if so, how? And if you can't, why not? So can you come out ahead? Can you gain more money than the taxman earns? Netting a profit.
Right, so obviously, I've at least thought about this a little bit.
Yeah, I've thought about this quite a bit. I actually do know a strategy that is optimal, but I don't want to say too much unless you want to go there.
Well, I think I did on stream the first time, but the obvious solution here, or at least the obvious first move, if anybody has seen it, is to decide to go and pick the one highest prime number that we possibly could. So our first move here should be the number 11. And actually, let's change that. Oops. Ah.
Now, Obi, you gotta address why. Like, we can't just say that. Like, that's not a. There's got to be a reason.
Right. So, reason being, once students have figured this out, this is going to be their first move, because they're going to see this and say, okay, I want to maximize my personal gain on this and therefore also minimize the taxman's personal gain, or, well, professional gain, I suppose.
That's professional gain, yeah, I was going to say.
Totally not personal gain. Right, so here we definitely still have one number that is available for the taxman to take, and that is 1. Taxman always needs to have one envelope taken every round, and so therefore we can't select, well, we couldn't select the number 1, for example, and then just start picking them up 1, 2, 3, 4, etc., because that would be super easy. So every time that we collect an envelope, taxman also needs to collect an envelope. So at this point, my brain was saying, how many possible factors do we have going across the board for every single number? So I want to pick the largest number that only has 2 as a factor remaining. This could work this way. Alternatively, we can go about it a slightly different way and just say, like, how many factors do each of the largest numbers then have? So since 1 is already taken, 9 only has 3 remaining.
And that makes sense. You now net a $6 gain, right? You net $6 there.
Yep.
So if I think about this in net, as far as like a who's ahead, I'm ahead by 6 plus 10 or $16 at this point.
Yep.
Right.
At this point, also, we could pick.
So there's a few things, right? Like this gets into some interesting discussion, because what do you do next? The next, if I take 10,
Yep.
I have factors of 2 and 5, right?
2 and 5.
I lose 2 and 5. If I take 6, then I get a gain of 4, which might be a good idea, except then I have to think about 12 later, because 12 has 2, 6, and 4.
But if we do that immediately, if we pull 6 and lose 2, then we can immediately pull 12 and only lose 4.
We lose 8, though. So, like, by doing that, we lose the 8,
okay.
and basically come out with 0. So we want to be careful. Like, I think though, one thing. So the 7 is the taxman's. I think we can say.
And the 5.
7 is taxman, and the 5. 5 is taxman's as well. So we don't even want to think about those.
Yeah, because these are prime numbers. There are no. The only one that the taxman could take is 1, and obviously can't take it anymore. So
that's right.
Those are forfeit.
So those are forfeited. So it comes down to which ones are the most advantageous to take. I can take. I think what we want to do here is take. So if we take 6 and 8, right, then 12 is forfeited, because then 2 and 4 are taken, 6 and 8 are taken, and then that's no good.
But
we could take 10.
If we go for 10 now, the only one we actually lose is 2, because the 5 was already gone.
But we lose 6 as well. Or no, we don't. We don't lose 6. Never mind. You're right. Right. So you take the 10.
No, we do lose 6 because 2's gone.
No, we'll get it through 12. So then go to 8, and then we
Oh,
lose
we lose it
4.
to 12. Okay, yeah, yeah.
That's right. So we lose it
Go
to
to
12.
8,
We take
lose
8,
4,
lose to 4, and then take
take
12 and
12,
lose to
lose
6.
6. Yeah. Okay,
That's
so
right.
now we've taken
So,
the 5 highest envelopes out of all of it.
right.
So this is obviously the optimal result.
Yeah, this is what you want. And if we look at it now, we got a score of, us. We got 8, 9, 10, 11, 12. That's 20, 40, $50. And then the other 7, when I add those together, come to 6, 10, 15, 21, $28, which is a massive, massive win there.
Yep, and n plus 1 over 2.
Right? Now, what's interesting about this is the way we were reasoning is not very like algorithmic at this point, right? Like we're not trying to we don't have like there it seems that there's an algorithm emerging, but it's not like there's a straight up I can have you do like integration by parts or complete the square or something like that. It's not that kind of algorithm. But yet there are strategies we can employ, and we're thinking about factors, right? If I'm thinking about this from a factoring perspective, I'm thinking about what factors are left that are um, that like how can I minimize the number of factors that haven't been taken? Erase my messy handwriting because that's I don't need that.
It may have been behind the palette for me, so that's all right.
We're gonna change over to purple just because it's one of my favorite colors to use on a chalkboard anyway.
Nice.
Right, so there you go. Now you can expand this problem and pick other numbers, right? So I can
Yep.
pick 30. I've seen it done with 30. I've seen it done with like 18. There are a number of things. 24.
Are there any
are good.
particular numbers that educators will pick as the n?
As the n,
Yeah.
12 is the most common starting point.
Right. This is easy enough. Yeah.
This is
Can
fine.
be done in a
This is
couple
fine.
minutes.
I think so. When I've run this before, we don't usually get past this point.
Mm-hmm.
Like I don't do it very often.
And again,
But-
sorry, this was high school?
This was high school, yeah. Like, and I even did this with elementary educators. I want to say, I might have done it with them. I'm trying to remember. Did we did other games with them? I think. Not
Yeah.
this one.
Definitely elementary education classes are like the group that you'd really want to get hooked on this sort of stuff.
That's right. Well, we did other things like the locker problem with them, or like there's a really fun. I ought to teach you a fun game if you know Sarah Vanderwerf. There's a game called 5x5.
Might have heard
It's really
of her.
sort of cool.
Yeah.
It's about cards and you place them in. I have to show you how it works. It's really cool. I might get to that. I want to stay on the taxman problem for now. but anyway, order of order of elimination matters. Yep. But again, this is a very non-algorithmic process. Like I mean, it's algorithmic, but it's not in the sense of I can repeatably get an answer. Like you wouldn't put this as a fill in the blank exercise on IXL, for instance, or any other online platform, Khan Academy. You wouldn't expect somebody to just do this in an online homework format. You'd expect them to, discuss with a team or discuss with an instructor or something like that. This is an interactive exercise, like we're doing here. But yeah, the point here is to get people thinking about mathematics without focusing on any particular curriculum. And we often call this a non-curricular task, which stay tuned for next week. We're going to be talking about this more with Penn Center. So
Nice.
stay tuned for Penn Center's stream. I don't mean to promote.
Oh,
here.
no.
Like,
of course. This is
this is like
everybody's
this is
heard
review.
this. Everybody's heard me say this plenty on this stream and many other streams. Like, the rising tides raise all ships. We want as much exposure to, and for anybody who hasn't heard this speech before, we want as much exposure to this EduTwitch community that we have going. just to, get the knowledge out there that Twitch has an
Right.
educational side. If anybody
It does.
doesn't know, like the Knowledge Fellowship, Moohoodles, Dr. Gold,
Yep.
Zach at etothe2ipi, um, and Penn Center, and everybody else that we hang out with. Um, Everybody has an interesting and different perspective on all sorts of like of the problems, and I recommend that anybody who has any particular questions get as many different perspectives as you can on it, because it definitely helps seeing problems from different perspectives, having a different person analyze, discuss, and try and figure stuff out. And just being exposed to all of those different things is it, like does amazing things to your brain as, I mean, as a human, but especially as a student.
Yep. 100%. 100%. Okay. So yeah, start with the so one strategy here is to start with the highest prime and try to get what are you writing down, right? Get single
Yeah, single
I don't know where you're
factor,
going with that.
single
Uh,
factor elimination.
that's right. So highest prime is a good first choice because it eliminates the one, right? That's sort of the goal here is
Yep.
to get rid of the one first, and then, as you say, try and eliminate the next smallest thing. That would be my
Or
way to
even
think about it first,
if
like
it
the
if it could
two.
be, it doesn't even matter if it's one single prime. That'd be really awesome.
Yeah. hmm Another good candidate that I found when you work these problems, or when you're thinking about this, is to get rid of perfect squares
Mm.
that are especially squares of primes. For example, we chose 9 next, and the reason for that was because it's a square of an odd number, right?
Yep. And 3 being um, prime itself,
That's right.
and the only factor of 9. That really
Yeah, square of a
helps
prime
out.
number.
There it is.
Yes. Did I say odd? I meant prime.
I gotcha.
I can. Okay, so the idea is
It's been a long day.
take those. Yeah, it hasn't really for you. It has been. It's like 1:30 right here. You're for you're gonna go at 9:30 right now.
8:30.
8:30. Okay, so it's not so bad, but even so,
And this is earlier than usual.
yeah,
So it makes it. I've got an
yeah,
extra hour of energy.
which is good. That's
Oh
good.
yeah.
So yeah, highest prime. Take out the perfect squares that are squares of primes. Um, that's probably your next best bet
If anybody's seen
because
this
that will
one,
match.
sorry. This is Prime Climb from.
Ooh, I've never seen that before. What is this?
It's called Prime
Looks like
Climb,
okay.
and basically there's a whole bunch of different rules, but it's from Math for Love, either
Okay.
the number or the word spelled out.
I want to say I've
FOR.
heard of that. Yeah.
So the idea is that you roll 2 dice, and then from wherever you are, where you start at 0, you have 2 pawns that you move. You can either do an additive move or a multiplicative move, or as the game goes on, you can then subtract and divide as necessary by each of the individual dice, or I think you can. Yeah, you can only multiply and divide by one single die, so it's just that. But add and subtract the other 2 in any order. And you're trying to get your pawn to 101. And then once you get
the
once you
the
get
large, the smallest one, 3-digit prime. That's wonderful.
yep. So once you get your both of your pawns to 101, then you win the game. Um, our kids are very frustrated that we're good at this,
Yeah, that would be some.
but
That would be something.
it also comes with a sheet which shows the numbers of and which primes, single digit primes, are, well, I guess it shows the higher ones too, but
Wow.
are the factors of each of the numbers from 1 to 100. So it
Oh,
breaks up
cool.
each one as like a wheel, and then you can see like the separation between them. Hopefully you can actually see some of that, but
That's awesome.
this is one we got for our kids, years ago, and this was, I think, a pre-COVID purchase, and so I actually took a picture of the 10 by 10 chart and then started showing it to my students at the community college who were in the developmental algebra class. So it really helped some of them, at least, kind of visualize, what are the factors of these numbers and what can I do with them.
Yeah. Cool. That's cool. Okay, so the idea here, like you're writing down with this algorithm. Let me see here. Sorry, I was checking something.
No worries.
Okay, so start with the highest prime, trying to get a single factor. It eliminates one single number, preferably the primes, or squares of primes, as the case may be. But the point is, like and as you're writing here, that's what I was going for.
Yep.
You talk about non-curricular tasks, and a non-curricular task is one that does not tie to a standard. So things you might tie to a standard are things like, I mentioned completing the square or integration by parts, things that you learn in school math, right? And you can look at many governments have a set of standards. I know in the States, for example, we have individual states will have different standards. You'll hear about the Common Core, that kind of thing. But the point of this is that you're not doing something that develops an algorithm to pass a standardized test. And if I can define curricular that way, I think that's like the informal definition I'd go with. It's just that you're not gearing yourselves towards doing something that is mandated by your by what how did he put it in the book? He said he uses a word that, like, it's not structurally required. Something that the structure, whether it's a government system or a private school or wherever you are, he uses a word in here, and I'm trying to remember how he said it.
It's all right. It's in chapter 1. I'll find it.
Yeah, it's in here. I know it. Like, I'll find it find it real fast. The institutional normative structures. I mean, that's not the one, but it's just by your institution, in essence. Because I know there's another word, but anyway. But so, I guess the point, though, in saying that there's even a difference at all, this curricular versus non-curricular, is when you do a thinking task, if you want students to think, you have to give them something where there isn't really a target first, right? You give them something or you don't have like a specific, I'm trying to build towards this thing, because that tends to shut off thinking. The students will say, I want an answer right now. You have to set a norm, and it goes back to an adage that I learned back when I was in my teaching career, that you teach old things in a new way, or you teach new things in an old way. But you never teach new things in a new way or old things in an old way. Because if you do it in an old way, you end up having kids be bored. If you have a new in a new way, that tends to be almost too much for students to handle. You need to give them some level of familiarity.
Yep.
So if I'm going to give them something new in an old way or an old in a new way, right? I want to pick a task, and this is a really good factoring task, but I'm trying to teach them something new about factoring. I want them to think about factoring differently and not have this necessarily, I'm not trying to build something that is, I'm trying to get them to think using old content, I guess is what I'm trying to say. And if my goal is to help them think and use and develop new skills in thinking, I need to do that using very familiar content, and this is very familiar content for many. And depending on your context, Liljedahl even says, like, you might even go to a younger group and say, which is bigger, 8 or 9? Or if you want to memify it, you could say, which is bigger, 6 or 7?
Boo!
Right. In the book, he uses 8 or 9, but I'm just going to memify it because he wouldn't have known. He wouldn't have known the cultural phenomenon that is 67. You can't. You can't. I can't pass up the opportunity.
It
So
is. It is just a meme for meme's sake, right?
it is. It's a meme for
Okay.
meme's sake. It literally is. Like I've looked into this. Dictionary.com apparently stated it's the word of the year, and we have no idea what it means.
Cool.
So,
April
so,
Fool's
so
Day.
there you go. But there's your official word of the day. Is 67.
Oh man.
But it is strictly a meme, and I say that though because the require when you think about a thinking task requires you to actually to do something to do some problem solving with math that's intentionally not algorithmic, right? It's not something that you have a preset algorithm to do. For somebody like you and me, if we're talking about whether 6 or 7 is bigger, that might be uninteresting. But to a kindergartner, that might be a very interesting question and something that's not obvious
Yeah.
at first, right? So your audience dictates whether something is a thinking task or not.
It wasn't routinization. That's something different because that's
No, that's to
talking
make
about.
something a routine. That's the
Yeah.
algorithmic skill part,
Yeah.
right? You're that's he.
Maybe it
I know
wasn't
what you're
chapter one.
looking for. I know it's in here. Darn it! Like the um
Anyway.
where it's probably actually in chapter 15 where it talks about all
Oh,
the
okay.
Q&A and like all the objections that people have.
Yeah.
Or was it which one has the objections? Isn't it 15?
To the whole framework.
Yeah, because I know there's a point where he goes through and says like, but what about this? Uh, it might have been in an
It's
individual chapter then.
pseudo-sequential stuff. Yeah.
Yeah. Um. Uh. Darn it! I'm gonna find it. This is really jurisdiction. Yeah, it's just in my jurisdiction. That's the word I was looking for. He
Oh, okay.
uses the word jurisdiction for this. Um, I was bothered by the fact that I couldn't remember. Like your jurisdiction will tell you whether to report out grades every quarter, every semester, every year,
Yep.
or and what your restraints are and what you can count for grades. I've even heard
Mm.
that can matter to certain governments or different stakeholders. It doesn't just depends on your country, and that's where it's specific to. Like Canada is very different than the U.S. I've come
Yep.
to learn in reading this book. For example. Anyway, but again, non-curricular tasks, you want to give people an opportunity to problem solve in a safe way. And do so that is with familiar content. And I'll just use the phrase because this is how it was taught to me, not in Liljedahl's context, but you're teaching old content in a new way. We're asking for engagement in a new way. So, there you go. Now, here's, and I'm gonna, you're helping me get ready for next Monday, actually, in talking about this, because as I'm getting my thoughts together for next Monday, and so this is a nice practice for me. But where this is what happens, and I've seen this happen in various contexts. Okay, people love Liljedahl for this, taxman problem. This is an excellent problem. I
Yep.
love this problem. It has a lot of good math in it. But what ends up happening is I've seen teachers stop there and say
Uh-huh.
they've implemented Liljedahl. But what they'll do is they'll just give these non-curricular tasks maybe somewhat periodically, so say weekly
Yep.
or monthly or whatever, and say this is Liljedahl. I'm practicing Liljedahl, and what I find is that's not how Liljedahl operates at all. There are 3 kinds of things he has you do. And the fact that we see non-curricular here should make you think, well, what about curricular tasks? Because we do a lot of stuff in math that's not that is curricular. We're
Right.
supposed to make sure that they come away, say you're teaching 6th grade. One of the key understandings you come away with is what is a ratio and what is a proportion. And if you're going to claim to have taught them that, you have to deal with the curriculum. Like there are certain things I gotta talk about ratios and proportions. As much as I love factoring, that's only one aspect of the whole year,
Yep.
right? I got to make sure I have a professional responsibility to make sure I teach the breadth of content that I'm expected to. And sometimes that's not it's you're given too much and that's not your fault. Like but you also have to try to at least engage with it, right? You've got to do something to build understanding. And yes, there are standardized exams, but those are I have not I'm not very fond of them personally. But nonetheless, they exist, and we need to make sure that we're doing something to help prepare. So to jump over to something else, what about curricular tasks? What about tasks that tie to things we learn, that are we're expected to learn? His classic example would be factoring, if I had to pick one from him. But there's many others you could use. And curricular thinking tasks, the only difference is really the content. You're still doing thinking tasks, but you're helping students think about whatever content is of the day. The purpose of the non-curricular task is to help you learn how to think about problems deeply, right? So, and ideally, these problems have open-ended solutions. In the taxman problem case, there's a very creative way we can create an algorithm. But with curricular tasks, often there are algorithms that we develop, but we have to have students think about them and maybe develop the algorithms themselves. This is where I'm going to bring in some other researchers that I'm familiar with. James Cangelosi, who's one of the members of my committee, and he wrote a book that's used for secondary educators, talks about different learning levels. And when you G, it's a G, Cangelosi. Here, yeah, you're good. Cangelosi wrote this book. So learning levels. He's done lots of work in assessment literature, and he talks about how you discover create when you learn mathematics. There are different ways you can engage. You can engage constructing a concept. You can engage discovering a relationship. If you want to write these down, you can, because these are all like. I'll let you take a moment.
I'm good.
Yeah. So construct. He actually calls it constructing a concept, discovering a relationship, simple knowledge, which you might think of as like fill in the blank tasks. Things like, the definition of the sine function is blah, right? Is the ratio of what two things. That's a simple knowledge task. An algorithmic skill. You also can have application tasks where you maybe apply something to a real world context. And then you can have creative thinking tasks, which are, like, as the name implies, you're trying to be creative and use mathematics in a novel way, maybe in a very obtuse way. Okay, these are all, and in these, to him, he would say never. It's not like you have to teach these in this order. They're just different ways of engaging with mathematics, right? So when we talk about a curricular task, we need to think about the how we want to focus on the conceptual and relational. I feel like if I were to tie these two things together, we'd be focusing on the constructing a concept and discovering a relationship, thereby developing the simple knowledge and algorithmic skill. To me, those two lead to each other, right? I personally see these as like, because he says these are things that come. In some senses, they develop those things. While you don't have to necessarily go in this order, and he would, if you were to ask him, he would say these are not an ordered list. In this, you don't have to engage in this way. But I would say that, just in my opinion, the conceptual and relational develop these things. That you are so to give an example, we can talk about. But one of my favorite tasks is that I would give students is let me think of a good one. When we talk about infinite series, So I'm going to use this as like a geometric series, right? Imagine you have a geometric series like with a common ratio of 1/2. You can make one up. Okay. So just make a geometric series, common ratio of 1/2. You can maybe start them all at 1 if you like, just because.
I'm just
So
going to be difficult.
do
It's
the
fine.
set from 1 to. We start from 2. Great. That's wonderful. Or yeah, even better. Great. Start with 2. Cool. That'll be a ratio of 3, right?
Yes. Oh yeah, I suppose.
Yeah. So we're doing R 1/2. Be careful. You can
Hey,
just change the R equals 3.
there you go.
Change the R equals 3. We're good. So say I do that, and then let's contrast that with maybe R equals 1/2. Still start at 2. I'll maybe make another one down here. Maybe we'll make another one. How about R equals -1/4, right? And we'll do 2. See if I can see my horrible mouse handwriting.
I did that for far too long before I finally found the original Wacom bamboo tablet that I was using when I first started streaming here.
Hashtag not sponsored.
Oh my goodness. Definitely not. But it was they wouldn't want me.
Okay.
But yeah,
But like
it had such a it was like super old and had such a terrible resolution, but you know, it got the job done. Anyway.
well so what I might do, I'll just fill in one more for funsies. What I might do is I might make a list of these sequences, and we'll not go to series quite yet. Can't draw a curly bracket. There we go. So I have these sequences, and I have students look at them and say, what do you notice about these sequences? You know, I'd have them compare and contrast these sequences. And this would be a very construct a concept type thing, like trying to understand what's going on. Can I predict the next few terms? Can I figure out what's happening in the long run? I might not even use the word limit yet, just to say, hey, what's happening in the long run with each of these sequences? What do you notice? Well, can I predict a few terms out?
So
And
if we're
then
talking like this is pre-calc level, isn't it? Or are you doing
maybe like
even
let's
earlier?
just pretend you could, let's just say pre-calculus for the sake of argument. Okay, you could arguably do this with a calculus course. You could do this with the earlier. It just depends on your goals, right? But if my goal is to help students understand conditions on which a geometric series converges or diverges, I would start with this and say, okay, let's identify first what a geometric series sequence is and say these are all geometric. What do you notice about them? Right? So, and students would be like, okay, well, I notice in the R equals 3 case, let's multiply each number by 3. It looks like each number is being multiplied by 3 in succession. So 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54, and so on and so forth. So the next number in the sequence would be 486. Okay? Or then if I look down here at the B end and I say, well, look, all the numbers seem to be getting cut in half. So the next one would be 1 over 32, 1 over 64, and so on and so forth, right? And depending on what I'm trying to emphasize, I might take off this R equals 1/2 thing and just show these sequences and say, well, can you find what's next? Can you tell me what's happening in the long run? And in doing that, students will notice a few things. As we were talking about, students might even draw these little arrows and say, well, this is like a multiplying by 3, right? Multiply by 3, multiply by 3, and so on. And I can say, oh, well, that must be what's going on here. And then I'd have some maybe contrasting cases. Maybe I have something geometric down here, like one, or arithmetic rather, 5, 9, 13, 17, and say, well, this one's different. This one doesn't seem to have. So I go through all these and I realize, oh, look, I'm having these all multiply in some way. A, B, C, and D, N all seem to have a multiplicative pattern between each term. But En doesn't have that. Right?
Mm-hmm.
So why is this different? Why it doesn't fit? I've now thrown a wrench in things, and I'm like, okay, so these all seem to fit in what A, B, C, and Dn seem to have a common relationship. En is outside. And just for funsies, if you want, you could even throw in a second one to throw them off. Say, okay, well, like, not throw them off, but just to get them thinking. Throw in the Fibonacci sequence.
Well, of course, it's going
right?
to be F sub n, so.
Of course. Right? So Fn, I throw in another sequence and say, well, that seems to break the rules too. It's not geometric. And they have to think about why that's true. They're now contrasting cases. So I've now specifically started, I've scaffolded a task to help students think about what a geometric series is and also what it isn't. Because I need to have examples of is and isn't before, and then I can start doing other things. Depending on my goals, I can say, well, maybe my goal is to be able to write an explicit expression for a convergent geometric series or sequence. Or maybe it's to determine when a geometric sequence converges. Or maybe, depending on my curricular goals, I can take this task and scaffold it in a way I want to have meaning, right? And you can imagine different pathways we could go, where predicting the next term would maybe focus on whether a geometric sequence converges or diverges. Or we could say, what is the common ratio? I could have students calculate that if I'm focusing on that that aspect. And you could scaffold questions in here based on your goals.
Yep.
But these are the curricular thinking tasks that you might see in a pre-calculus classroom, right? I'm trying to help students understand this geometric progression, and in order to do that, I define my goals, which we should do. So let's define a goal. So if I'm going to, I'll type it over here. This is where planning comes in. I'm over on the left. In purple.
There we go.
little to the left. There you go. So my goal, students will define a geometric sequence as a sequence with a constant ratio between consecutive terms. Okay, so if my goal is to help students understand that, then this task achieves my goal, right? And you could imagine a jurisdiction of any kind that has this as an objective somewhere, right? Like this might be a curricular task, something I would expect students to learn in a school mathematics context.
Yep.
You could also have the goal saying students will recognize that a geometric sequence converges, or I might say recognizes conditions under which a geometric sequence converges or diverges. And if you wanted to be more specific here, you could when I write objectives like this, I try not to give away the mathematics because I know that we're talking about the common ratio, the magnitude of the common ratio being less than 1 or greater than 1.
Yep.
I don't want to say that on the board because that kills the thinking, right? That's counterproductive for the student. Because then if I put it on the board, then and this is why I hate written objectives, personally. When you get people saying, you have to put your objective on the board. Like, no, you don't. I will fight you to the death.
It's a surprise.
It's supposed to be a surprise, right? I'm only saying, like, I will fight this issue because it kills thinking to put it up there. You want students problem solving, and you want them to have the same engagement that they had with this taxman problem, which is very engaging, and it gets them thinking. It gets them engaging with math in a new way. That's how I'm
Yep.
going to define thinking. Like they're having to use mathematics in an authentic way.
Hmm.
And if I want that same thing to happen, I need to structure a task so that it doesn't have an algorithmic skill focus. I can predict what comes next in this sequence, right? I can, the way this task is set up, I can look at these sequences and say, well, look, there's some kind of multiplication going on. And I can even pull out calculators. This is calculator friendly. If you need to have the support of, if somebody doesn't know their arithmetic well, then and they need some support, you could let them use calculators and there's no shame. And you
Yep.
try and pick numbers that are reasonable at first, and then you start getting into more challenging patterns. Once you've established what a geometric sequence is, then I have some things in my back pocket saying, okay, now that you understand the difference, can you make your own? Or can you make it so that, like, can you make a geometric sequence with all terms negative? You start pulling in other questions, right? Like to get
Hmm.
them pushing towards different applications of these goals. And depending on what your target is for the day, you'll want to ask different questions. This is the hard part though, because you have so much to manage in the classroom, right? You have people who are in different positions and like some students are maybe struggling getting started.
Yep.
Some students may need some may be well ahead. You have sometimes the opposite problem where students are very much like getting it and they just want more and more and more and more. And you've got to somehow balance these things. But having I know Liljedahl will talk about cue cards, right?
Hmm.
Like these things you can give tables where you as a teacher can have these maybe in the sequence context have specific sequences you can give them or different challenges you can give them to extend their thinking past what they know. Right? You're
Right.
taking notes as you go through here every day.
So he also says you don't want to have a like stack of
Right.
cards or something like that that's visible to the
Right.
students because they'll start thinking, we just have to get through it, and then we can go screw around and play on our phones or whatever.
That's right.
So I wrote somewhere up there, oh yeah, just next to us, that we want like a near infinite possible questions to ask, where you certainly are going to fill the time if you just give out those questions, but nonetheless, it's just basically showing the students that no, you're not getting through this. You're not trying to get to an end goal. You're trying to actually just learn it.
But let me be clear. I'm going to slightly disagree with what you said because I like what you said, but I
To a
also
point.
don't like
That's
what you said to a point, right? Like because you want what you want. You do have a goal for the day. You do want to achieve your goal, and there are ways to tell whether you have achieved my goal. So, for
Hmm.
instance, I can tell whether someone can tell the difference between a geometric and non-geometric sequence. There is a specific way I can tell that,
Sure.
and there's a specific test we can run, right? And I take data on that. And that's part of the responsibility of the instructor or the
Yep.
facilitator, however you want to call it. But I need to make sure that my students get there and that all of my students get there. So if I am responsible, say, for 20, 25, 30, 40 students, however many, my job as the instructor is to make sure that they get there and that they're thinking their way through it. So I have to make sure, again, like, make sure that you are doing your part to, like, as the instructor, going and you're monitoring. This is not a time for an instructor to sit down and just chill on their phone, because that happens too. But like to go and really dig in with students and engage with what they're thinking about, for example, in the
Yep.
geometric sequence. And if you're seeing them think about, for example, common differences, then you know, okay, they're thinking arithmetically, not geometrically.
Yep.
So I need to be pushing them towards geometric reasoning, and maybe I need to show more examples of this and show them, look, this thing doesn't have any common differences at all. You notice how all the differences are different. Maybe there's something to that. But down here we have ones that are the same. like the common differences are the same. So this somehow fits in a different category. What other operations can we try? And there are lots of other scaffolding questions we could ask
Yep.
that are dependent on the student.
And for anybody who is an educator out there and doesn't either know how to do that or hasn't practiced doing that, I mean, Zach and I both have taught a lot of sessions involving leading questions. So
Yeah, you may
I'm sure we have many different ways to come up with similar.
sure. I was going to say
Similar
there's
results.
lots of different options, but it comes down to the specific student you have.
Yep.
Because not every student. If there was one way to do this, AI would have solved this problem long ago.
Yep.
Honestly speaking, and this is one of the people will have one of the things that AI doesn't do well is be able to predict good questions to ask next because it's not taking into account and respecting what the students are thinking and doing.
Right. Most of the AI actually learning occurs offline elsewhere and doesn't actually affect the future results until the programmers actually work that in.
Yeah, that's right. That's right. Okay, good. So that's a non-curricular task, or a curricular task, sorry. Now, Liljedahl talks about a third class, and like actually divides this into two classes, because really, they're in page 28 of his book. This is the we're actually like I said, this is the part on. So we're going with curricular tasks right now, where you have some curriculum you're tying things to. But he specifically breaks this into two groups. You have those that are scripted and those that are as is.
Yep.
If you want to write those down,
And
this is
these
good to
little-
it'd be good to
this thing
emphasize.
right here.
Okay.
And this will blip out in just a little bit for an ad break. However,
Maybe this is a good time to take it. This is a good a good break.
okay.
Let's go ahead and take
Just
it.
before we
and then,
get that.
give me a second to before we jump into a different topic.
Sure. We got like 3 minutes or 8 minutes if we want to finish this one.
Let's can we take it now?
Yeah, sure.
Can we do? Let's take it now,
That sounds
and then we'll
great.
come back to we'll do the next part next.
All right.
See you in a minute.
Well, yep. Thank you, Zach, and thank you everybody for coming. We'll be back in 3 minutes. Get up, stretch, do your taxes.
Yeah.
Whatever it's going to be. And we'll catch you in just a few. Thanks, everybody. All right, and we're back.
Okay, welcome back, everybody. Few things. Okay, so scripted, not and as is. I want to just say before we go into this, um, these are as is curricular tasks. Sorry, these are curricular tasks. So the adjective here would be scripted curricular, I think.
Yep.
That's what we're focusing. Just want to make sure that this is reflected properly in the record because I don't want people because what I don't want is necessarily these to become thinking tasks, and he does not say these are necessarily thinking tasks.
Right, and that's one of the problems with the as is, but we'll get there.
Right. So here's the thing. In the example we have with the geometric sequences, if we go over there for a second, I might give a script to this where, so I mean, yeah, I'll let you finish writing.
No, that's fine.
So like, as it stands, I can go and give a group. I can get huddle people around me, and I know you've talked about this where you give the task orally. Say I give this sequence to a group of students on a vertical non-perpendicular surface. I'm presuming we've already talked about that. So
Yep.
but the idea here is I show them this, and we have a conversation about what makes this geometric, right? And then I say, okay, or what makes this thing unique, and say, here are these other 4 or 5 sequences. How do they compare to this one? Like, can you put them into groups, right? Like maybe there's something special about this one, and maybe show another. Maybe we can talk about a second and say, can I sort these other sequences into groups? That script, he's calling it. The idea that I have this first thing, I show them something, this looks interesting, and then I ask them to sort things into groups. That is called a scripted curricular task in his parlance. In other words, I have a script of a sequence of sequences. I don't mean to be confusing here, but it's a sequence of sequences that are intentionally scripted to help me see whether students can connect what a geometric sequence is versus what is, right? So I have the sequence that's already developed, and that is a sequence curricular task. It is a sequence of tasks that is tied to a curriculum. Now, an alternative here, if I were to take this same thing, and I guess you can write, we take that moment and write. I don't want to lose the. I don't know when you're going to write or when you're not, so I'll have to pause more often than I'm used to.
One more time, just for that. There's a sequence of tasks.
So a sequence of tasks that is tied to a curriculum. I mean, it just as the name implies, right? He might have used different words here, but the idea is the same.
All right, we're good.
Okay, so as is. If I were, I don't necessarily like that phrase, just because it's different from what I'm trying to tie it to something real here. But take this same sequence. You could imagine a PowerPoint presentation where I literally go through and say, oh, look, kids, everything I'm multiplying by 3 between each term. So the next term is 486 in AN. And look, BN, I'm doing the work here, by the way. As the instructor, I'm having the kids all sitting in their desks. I'm up the board, and I'm writing down, oh, look, the next term in BN, it looks like I'm dividing each term by 2 or multiplying by 1/2. So the next term in sequence must be 1/32. I am literally doing the work for the student in that case. The difference here is not so much what the task is, but what I'm asking the students to engage with. I'm asking them to look at what I'm doing and mimic me, which he would use the word mimicking to describe what most people would do in this situation, right? And here's my sequence. I'm just going to have you copy this at the whiteboard or on your desks. Do your thing. And by the way, here's C. You can try C on your own. I'm going to walk around and just see if you can do it.
Yep.
Right? Can you tell me what comes next? I'm not asking them to do anything, any thinking. I'm not asking them to engage the same way. And the question here is how I'm asking the students to engage. I have intentionally, in the first set, if I say, here's an interesting sequence, what do you notice about it? I'm not saying anything about um, how to do the problem, what to notice, or anything like that. But I am asking students, like I'm asking them to engage. I'm asking them to do something, to do the thinking, to do the hard work of making the connection to my goal for the day, which is geometric sequences. Versus if I get up and say, "Here are my examples," and well, now you try one. They're just copying what I'm doing. That's the mimicry that he would talk about. That is quintessential to an as is script or an as is curricular task.
Which I think I've mentioned this before, but I felt really called out at the beginning of everything when he said, students who did this, that, and the other, who completed these, who like would look back for examples and do all this, are called mimicking, and I went, oh no.
Yeah, well,
that was
that's
that was
but
my
that's what
entire
happens. Yeah,
experience in high school and even part of college.
and it's not even shameful to admit that because I've done the same thing. I was in those shoes. I used to think that teaching was just giving people worksheets
Yep,
and telling people what to do.
yep,
Right? I sat in my desk and like that was my kid understanding of what a teacher did. And frankly, many of my teachers did that to me. So
mm-hmm,
it's sort of
yeah, it matched.
okay. Like that is
Yeah,
reasonable. Like you're trying to break a cycle where you have been told to do one thing and there's like nothing wrong with being okay. Like this is just something we accept. Like we have to figure out like, okay, this is my pattern. I'm trying to break a cycle of something, and the first step is just realizing that there's an alternative,
yep,
right? And whether it's good or bad is I'll leave that up to you because that's a personal decision that every teacher has to make.
mm-hmm,
But I will say what Liljedahl would say here is that mimicking doesn't promote thinking, and that these two words you can consider opposites in his mind. That mimicry and thinking they serve very different purposes.
yep.
And
Not quite
mimicry, he
mutually
even
exclusive, but pretty close.
they're pretty close. And mimicry, he even admits, is something that is it can be effective if you're trying to mimic a specific algorithm,
Yep,
right? Like if that is your goal, that's reasonable. But that isn't our goal here. If our goal is to help people think and to develop things for themselves, then mimicry cannot be the answer.
yep,
But then this now see, and I think if we're honest, and I've had people come to me in various ways, or I've heard from secondhand stories, or even third hand stories of teachers who are like, "Well, we're just gonna have to tell them the answer eventually, right? Like, aren't we supposed to just give it to them? Like, for in our context of geometric sequences, aren't we supposed to say eventually that the magnitude of the common ratio needs to be less than one for convergence?" And I'd say, yeah, you eventually need to come to that conclusion, but you need to help students do that,
yep,
right? This is now both Dr. Liljedahl and myself talking because I'm sort of now meshing not exactly his words, but I'm now taking that with my personal experience and what other research I've gone through.
right.
You
So
want to
this,
help students develop the idea for themselves. This is going back to Cangelosi's idea of discovering a relationship. You want the students to be able to say the thing, or to and put another way, um, one article in an magazine once said, "Never say anything a kid can say"
yep,
by Reinhardt. And it's a seminal work for me. That's one of my favorite articles of all time. But the reason it is because that's what the students need to do the work. And the teacher needs to do the work to help the students see what they want them to see. And I think that falls very much in line with what Liljedahl would say.
right.
And
I would
he
argue
would
this
use the
fits
word
very,
consolidation.
yeah,
Yeah.
solidly in the consolidation section, where you are leading a discussion to help the students understand what is on all of the boards around the room. You are not, telling them what is on the boards around the room, and you're not just letting them freeform.
And this is very hard. I want to admit that what I'm saying right now is very hard to do in practice.
Yes.
It takes, and what would be fun? I've actually wanted to do this for my stream anyway. There's a set of videos from classrooms around the world that I have
Mm,
access to, that actually anyone can access, and I want to go through and watch them
hmm
and just show you like Japan is a master of this. They're experts at being able to help students see mathematical ideas, and like you watch the U.S. ones and they put us to shame. Like
Yep.
it's horrible. I've watched some of the U.S. Like, I just watched like 5 minutes of the U.S. one once, and I thought, oh my gosh, it makes me it makes me like cringe every time. It's just painful.
Yeah.
Um, and I'm saying that about like, yeah, I know what I'm saying here because
Oh yeah.
it's like, man,
I mean, even
there's so
myself,
many.
right? Like I, I would stand at the front of the classroom and I would ask a lot of questions, but I was only having conversations with two or three students,
That's right.
and
That's right.
so it was just a constant, not like stream of consciousness or anything, but it was just a constant hum of my voice with a few students interjecting here and there, and then asking, the ones who were paying attention and understanding asked really poignant, good questions. But like, half to three-quarters of the class wasn't paying attention at all.
Yeah.
Or they'd come
Well,
in and
and,
out,
and that's right. That's right. And you want to have maximal engagement, which if you now notice also this R equals 3 case that we show with AN over in our list. Ideally, these questions that you develop, these scripted tasks, would have the lowest effective filter you can possibly have, meaning it's the most accessible it can possibly be. You want to make it like the entry point so that anyone can enter the task. I mean, I'm trying to pick numbers that are reasonable here, but
hmm
later on, I might choose more difficult numbers to work with or more challenging numbers just to help students make the connections I want them to see.
Yep.
And depending on my audience, I might choose specific some numbers more than others, right?
Fractions can
And
always be fun.
fractions can always be fun, yeah. And like you did, you divided by two and not multiplied by one half. Which in my classroom, if that had happened, I would have like been like, oh shoot, they're not seeing the full connection I want them to make, right? It's almost like that could almost derail my lesson, and I have to think about like, is division by two what I want them to say, or do I want them to notice something about multiplying by one half?
Yeah.
And it is, I think, in that context, multiplying by one half would be better, just
True.
because it helps emphasize the ratio part,
Yeah.
and that, like, if I divide by two, that almost obscures the whole thing.
Yeah. And
Because I think,
obviously I
oh
did
well,
that
then
on purpose. So
I know, but I know that. But I'm saying that as an instructor, these are things you think about. If my goal is to think about common ratios, is division a common ratio? Well, yeah, sorta. Like not in the way that you might. You can connect it to ratios, but that representation can throw students off, and I'm glad you did because that's something we need to think about,
yeah.
and that promotes a question from the instructor. So
Right.
you'd want
So
to say something
almost
like, well,
almost certainly the next question would be, how else could we describe a division by two? And,
yeah,
most of the
or
levels that I teach would understand, oh, you meant multiplication, especially at this point, because we've already done exponential functions. So probably this question would have been addressed during the exponential function section
yeah,
for a
yeah.
pre-calc class.
Well, and what's interesting here is I might even let them go through the first four of these
hmm
and let them represent it how they will, and say, then,
What's going to happen on
okay, now
D?
that you've represented these four, now that you've done these four, how can you unify the way one way of expressing the relationship? Can you unify this so that all four of them follow a similar pattern? Right? So then
hmm
then that promotes the thinking of, okay, I need to think about, maybe could all of these be multiplication problems or all of these be division problems? And that might even be something to push for the other students that are ready for it. is to say, could you represent this another way? If they all jump to multiplication at first and they need an extension,
Mm-hmm.
I might say, can you represent these using some other operation? Right? Like, is there
Yep.
another? What other options are there, and why? And noticing reciprocals, for example,
Yeah.
as the case may be. For example. So now, in the book, as is curricular tasks don't really get much love, and there's reason for that. Like I think you and I have sort of alluded to why,
Right.
but
So this
these are the
is,
tasks we're used to.
in theory, right? The as is curricular task, yes, is something that we've already done, but it's the instructor has the voice in the classroom and is doing, as you said, most of the work. Maybe asking students to do something, but during the instruction part, it's mostly the instructor is doing the work, and then the students are just kind of taking notes, watching.
Yeah, yeah. And that's the kind of classroom that's for me a travesty to watch. It's always hard when I watch this classroom. I've done it and I've seen it, and like
Yep.
I've lived a lot of that. Um, and it's interesting from a more pragmatic point of view. When I ask teachers or when I've engaged with administrators on actually changing these things,
Mm-hmm.
the administrators range from indifference to even being somewhat not belligerent but just unaccepting.
Slightly hostile,
I
maybe,
wouldn't
but
say
not.
slightly hostile, but like I mean, there are some that were a little hostile, but I've only experienced really one or two cases where probably two cases where people were like openly accepting
Mm-hmm.
to the point that they were like I'll say three because I'll count like, there's actually three I can think of, but actually by and large many were indifferent or slightly negative towards it.
Mm-hmm.
And it's understandable why. Um, what Liljedahl is asking for from people is non-trivial
Mm-hmm.
and requires more work.
Yep.
If I'm honest, like that, this is the way. Like I'm trying to be honest all the time, right? But like if I just to emphasize, this is a very um, what the work involved in planning a lesson of this kind is very difficult
Yes.
for many,
Especially if
and
you're
you
not
have
used
to
to it.
have you're not used to it, right? Like and imagine if all you had was this book and you had to implement it, and they said go.
Yeah.
That's not a very supportive. Like I know that that's in some cases what teachers are up against.
Right.
It's
He
hard to show
does,
people
and he
what this
does
looks like.
offer multiple resources to try to get things going a little bit, but it still takes
Right.
time. It still takes effort that we just haven't expended before.
Yep. But geometric sequences are an awesome topic, and there's lots of other options you have for tasks. And actually, um, I don't want to say too much yet, but I have a project for 2026 that is related to what we're talking about,
Ooh.
and it's sort of a two-part thing that I've been it's been percolating for months, and I've now gotten to a point where I think I can articulate what I want to do, and you stay tuned for December because
All
December
right.
I'll be putting out some announcements in Discord and what's going to be going on. But I'm
Awesome.
getting to the point now where I just need to put together the framework on how this is going to work. I've wanted to do this for like years, and I've never actually had the guts to do it, or the I don't know how to say it. I've not known how to do it yet, and I finally think have a way that I can frame what I'm trying to do. You and Penn have inspired some things lately in light of these conversations about math education, and this actually will help. These conversations will help motivate me to do the thing I want to do that I've always wanted to do. So get excited for January when we start the project, and for December for the announcement of the project. Uh, I'm super nervous about it, but I'm also excited about it.
All right.
It is coming. Okay, so that's the kinds of tasks. Thank you for the shout outs. I appreciate that.
That'll work. Okay, anyway. Okay. Let's see. Do you have anything else in particular that you'd want to discuss for, like, connecting
For
theory
this part,
with how we do it?
with
Yeah.
practice, with how we do it. Well, there's lots. Let's say lots on this subject. I mean, we can go to town for hours. What I guess, I
Oh
know
no,
you had
you've seen through
mentioned
my
lesson
ruse.
planning. Yeah, no, I was gonna say, like you mentioned lesson planning. Tell me more about that. What kind of lesson planning? I know you mentioned that you wanted to do some lesson planning.
Yeah,
Uh,
so I mean, I'm thinking kind of like, how exactly do we go about um, working in um, doing the scripted curricular tasks? So we know that from I believe chapter 9, we want to make sure that it's that gradated step-by-step progression to keep the students in flow. And
mhm.
also, we want to make sure that we have sufficient hints and extensions to keep the students in that flow state without venturing too far into either, what was it, boredom or frustration.
Mhm. Yep.
So, I don't know if there was, if you have any advice on how educators might be able to um, leverage whatever resources they might have. Is there a good way to outline first and then start looking for tasks, or are we looking at mostly
Okay.
yeah, what's the
I
script
think I
versus whatever?
get. So let me try to rephrase your question.
Sure.
When you go into a classroom and say, like, I have something I'm trying to do for the day, pick your favorite thing. How do I make sure that the task is appropriate?
Not factoring, because we already got that one.
I get that. So let's pick something else. Factoring's great, but like, pick something. I want you to make the choice here because I think
Sure.
it needs to be useful for you, and I think it would be better to do this live in an authentic way where I have no idea what you're going to say,
Yeah.
and let's literally just like now let's be reasonable and don't pick anything outside of undergrad, okay? Like my math
No, no, no,
content
no, no,
knowledge
no.
is and like be kind here
I'm
if
gonna
you're going
be.
to pick
I
something,
mean, I'm
but
gonna stick
like
to pre-calc probably just because that's
that's great,
that's my specialty.
wonderful,
So
cool.
if we go with something probably mid-class, um,
Yeah, pick something that you think is somewhat difficult. Maybe we can, something that you always had a hard time teaching, or
oh man.
I think that could be more interesting than trying to pick something you're more comfortable with. Think of like the lower. The reason I chose series for my project,
Mm-hmm.
actually, for my master's, was because it was the hardest thing I knew and the hardest thing for students. So I think it would be useful if we pick something that you think is difficult for that you've seen in your experience that is difficult for students to understand, and we try to improve that thing. Right? Like maybe that's where we should start.
Yeah. Let me look at the table of contents here for. I'm gonna actually pop this on stream. Watch out, everybody! Flashbang out. So.
Yeah.
Okay, so we've got here the list of topics. Um, so chapter 1 is mostly going to be function properties.
Mhm.
Chapter 2, talking linear. We, in my class, because we're at the community college, we just like basically ran like 2.1 and 2.2 as you've already done this before, and we're just talking about the properties of linear functions and trying to set up the kind of way in which the class is going to run for the rest of the class. So we get, uh, what does a linear function look like in terms of its different forms, and then looking at what they graph as. We didn't really do
Mhm.
modeling or fitting data.
Fair enough.
Quadratics, exponential logs, polynomials. Maybe
Again,
let's
this
go
is
with
your
like.
choice, not mine. I think you should.
Yep. Let's go with rational functions.
Cool. So rational functions is a good topic, but let's be a little more specific. What do you
Yep.
want students to achieve with respect to rational functions? So I'm going to write this down as we go because I think this will guide our discussion.
So the ultimate goal here is going to be something like this one, where we're going to be graphing a more complex rational function, has multiple vertical asymptotes, horizontal asymptote that is not the x-axis, or potentially a slant asymptote.
Okay.
And probably either multiple zeros or, well, at least one. Or it goes through the asymptote itself, which is always fun.
Okay, so let me just try and consolidate what you're
That's
saying
okay.
here. I'm going to try to put this in words. So students will analyze rational functions to identify. I'm just writing as I'm thinking here. We'll analyze rational functions to identify asymptotes and zeros. Right? And then students will graph the rational function. So actually, we can put this in one thing. Analyze and graph rational functions. We'll analyze and graph the rational functions. Right? Am I picking out the key ideas you want to make sure students understand?
I think that's probably reasonable, yes.
Okay. So students will analyze rational functions to identify asymptotes and zeros and graph the rational functions.
Mm-hmm.
I guess we can put a comma here just to emphasize that this is
Yep.
These are two separate things. Okay.
And, realistically, it's all of the function properties that we have highlighted. So, analyze it to identify relevant properties, even.
I think we need to be okay. So this is again, there's like a publicly displayable goal, but think about this from your own perspective. Like if this were a lesson plan you had written in front of you, you, the mathematical master, I think can understand what this says. We're not putting this up for others to see yet.
Mm-hmm.
If I were having if I wanted to invite students to engage with like a different, like if I wanted a student engaging one, I might say, well, identify properties of rational functions. Maybe that would be more relevant for students.
I may also argue changing zeros to just intercepts, so it's a very neutral.
Sure. Okay, that's fine.
Intercepts. And that was my fault for picking that.
No, you're fine. I'm giving. No, you're that's great. Okay, so because I guess that's true because we could have vertical and horizontal asymptotes. That's a fair point. Now, if I'm going to Liljedahlify this and develop some tasks on this, what I need to do is I need to create what is the simplest thing I think a student could do with what's like the simplest rational function that has something interesting in it for students to engage with. Like what is give me like a function that any student could look at, or like is the simplest thing you could look at that still achieves this goal. Like think of your student who's like reticent to engage, has no idea what's going on. What could I give them that exposes them to what an irrational function is?
So do you mean like
a
an
specific
application.
rational function. No. A simple, a rational function. Just pick a rational function, any rational function
Hmm.
that a student is likely to at least look at and say, okay, I can maybe engage with this. Like maybe it doesn't look too crazy yet. That's wonderful. Okay, cool. So 1 over x plus 3 and 1 over x. Those are excellent. Okay, cool. Let's get another one just for funsies.
Of the same
Something
type.
else. Same type, yeah, that's why not. There are 2 up there. Uh, okay. I might even make the 2 negative,
Hmm. Yes.
right? Just because we want to. If you now, depending on your class, you might want to keep that 2 positive. Okay, there's reasons why you might do both. I could see this is where you have to know your class and be a little
Hmm.
more specific to the group you're with.
And this would
You could
probably
make
not
an
be next to each other, for the
uh,
specific reason that you only want to change one thing at a time.
sure. So like it depends on what you're. Again, I'm going to leave that to you as to
Hmm.
what. Maybe we'll leave it off for now. Let's leave that off. But the minus sign that is. But I'm going to try to. Okay. Okay. So here's my target. I think my goal again is to try and help students analyze functions. So what I might do is in my, I might take these ones you made. I'm just going to copy them. And I want to focus on what's called inductive reasoning. This is how literature might talk about it. I want students to sort of, or sometimes it's called abduction, right? Like they're sort of similar. It's more abduction here, but the idea is I want students to start noticing some patterns, and I want to do some of the work for them, scaffold this in a way that they can see some relationships, right? I want to emphasize important points. So, for example, if I just plot these functions, students may have seen 1 over x before. I expect you've I know you like to talk about parent functions, so they've
Right.
probably seen this before.
And at the very least, if they don't know how to do it, they at least know how to make a t-table and
Sure.
work with
But I
that.
would even give them this. Get rid of the work of making a t-table
Oh
because
no,
that's
I
not your
wouldn't do it.
focus.
It's just their
Right.
option.
Their option. Yeah, like they could, but I would actually give this. So if I were to show them a graph, I might pull up Desmos or something like that
Hmm.
and have them engage with just this picture and look at the y equals 1 over x and say,
Hmm.
that's interesting. And then I'd say, okay, here's a -3. I'm going to draw the same picture, right? Because that's what it basically is. Here's the graph. You could choose to put a dotted line here or not. I suppose it depends on what your
Hmm.
preference is, but we could throw a dotted line here. Um, and one more, right? So we've got this 5, and I'd have to make this a little bit more steep because there's a 2. But the idea is, students can start seeing, oh, there's this number. There's this like vertical line that always happens. And I might invite students to say, well, what do you notice about these 3 pictures, right? I look at these 3, and these are the functions that they represent. What's going on, right? Students can that's a low entry point to the task. It's the goal of the day. I want students to be able to see how an asymptote is affected by a horizontal shift or like these
Hmm.
noticing that like dividing by 0 at 3 is a problem. And so if I were introducing this task, I'd maybe show some pictures like this and say, what's going on here? Right? What do these three graphs have in common or not in common, as the case may be? And I might, let students percolate on that, let them come to some conclusions. Oh, it looks like if I move 3 units to the left, that's like adding 3 in the denominator. And they'll say, well, why is that? Right? Like, why would that happen? Or this -5. What is that doing? Why is it going to the right? Students might notice that there seems to be this left and rightness that somehow is affected by the denominator, and that's when we've now presented this interesting first act where I don't like it's like you're building a story and I have this intriguing narrative about the denominator's doing something. Why is the denominator doing something? What's going on here? And then I can launch them. That launches them into now a sequence of a scripted curricular task. I can now develop another, this extra list you're starting to put out there. I can now invite them to start drawing some graphs and say, what's happening in each of these next ones? What would you expect to happen? Why? How can we explain that? Draw those, and we even pull out Desmos if you like. Have them explore what's going to happen with this graph. This y equals 3 over 2x plus 7. What's going on there? What happens if I put a negative in the numerator, right? What does that do? What is it? And you can think of various variations on this. What happens if I put 2 asymptotes in? And why does that happen? And so on and so forth. And maybe the general form, exactly. You can start generalizing this. Good. So you can start seeing ultimately I want to get there.
Right. So this is the same function transformation. Oh no.
You don't want to go there too quickly, but that ultimately is one of my targets, right? That's one way to meet the target.
Right. So students would have in a pre-calculus class seen this in every single section before this. So I would expect at least one person to be like, "Oh my god, this thing again." And
but I want the students, based on my goal, I want students to identify asymptotes and intercepts.
Right.
So because of that, I want the students to be doing that.
Mm-hmm. Yep.
I don't want to do that for them. So I need to set up the stage so that they have a reason to explore the denominator. And so what your first 3 examples are actually very good in saying, okay, let's figure out what that denominator does. And really, they should come to the conclusion that at this point, the numerator does nothing. Right? The numerator is really it doesn't affect the asymptote in any way. It just affects the slantiness of things, but that's not relevant to my goal right now. If the first half of this is to look at asymptotes, I don't need to worry about intercepts quite yet. I mean, I will eventually, but to start off, if I'm going to give the lowest thing, at minimum, I want students to engage with. I might want them to engage with horizontal transformations of vertical asymptotes. You can imagine then, afterwards, after you've had the consolidation, you might jump into what happens if I have more things in the denominator, like a quadratic denominator that factors into 2 things, right?
Yep.
Or you can imagine what happens if I have a cubic in the denominator. There are 3 asymptotes, if you really want to go there. Or then I can start adding in zeros. Well, what's happening when I have a 0? And for those that are ready for it, I might even throw in oblique asymptotes or slant asymptotes. You can imagine how that could be done in a very similar way. Removable continuities, exactly. These are all things you build into the script. And that after you've established one of these properties, you can start adding in other properties as appropriate.
Alrighty.
All right. Does that get started? I mean, we can continue along these lines.
Yeah.
I'm just curious what the.
No, I mean this is certainly a good start.
So where would you go from here if you once you've established what a vertical asymptote looks like, maybe we can just decide what's the good next step.
Right. So probably, um, so based on what I've done in the past and the way the flow in which the rest of the lesson typically goes, what I had been doing is then continuing on with function transformation. Because the students have already seen it, they should be familiar with it by this point, and just say like, okay, so if you take the parent function, if you transform it in some way, this is what happens. Oh, look, it's the same as, going back to all of the other functions that we've done before. You take the parent function and you are shifting it around and stretching or compressing or flipping it in some way. And typically the way that I've been talking about this is you are going to be flipping this thing around what would be termed the origin point. So the new origin point is wherever 0, 0 has been shifted to. So
So
C
this is
comma
your
D.
origin, if you will. Yeah.
Yep. So C comma D is the new origin from which we measure all things. So our parent function in this case doesn't do something as simple as additive and subtractive amounts. This is going to be, okay, every time that we end up, we come from the initial point, 1 comma 1, we could see that if we go over to 2, we get to 1/2. The distances in this case are what really matter. Right? In this case, our distances have to be multiplicative inverses of each other.
Well, now, and let's be clear here. Is this tied to our goal right here? So the 1 to 1 and 2 to 1/2, like labeling these points, how does that tie to our goal?
So that helps the students graph these particular functions without the need for making a t-table.
I see. So I guess herein lies an interesting thought. What I'm hearing a subtext, and I don't know if I'm interpreting correctly. I want to make sure. Is the goal to make a picture perfect graph?
No, the
Or
goal is for
pixel
students
perfect?
to be able to very quickly, once they understand how it works, the goal is for them to be able to look at the pattern that exists and say, if this is a simple transformation of any particular function that I've done, in this case, obviously, a simple transformation of a rational function, then all I have to do for any of these is say, okay, what is the relationship that exists? In this case, it's an inverse operation. So if I want some quick points to be able to graph something pretty quickly, I can say, okay, we're going to start with the initial point, wherever that may be for this particular graph. Again, in the case of 1 over x plus 3, this exists at a location 1 over and 1, totally 1, up from this origin. The distances are still 1 and 1. Then, to get the next point, what I would need to do is say, okay, I want to double my x distance, and then that's going to cause me to halve my y distance. It's totally half.
So I guess let me make my point more plain.
Sure.
Is because I think is the way I so how do you feel about the way I've drawn these? Like, I mean,
So they
be
get
brutal here. If
they
you
get
want
the
to.
point across, but they're not particularly accurate.
Okay. And this is where this is what I guess I'm getting at. Is if I drew it like this, am I meeting the goal according to you?
I don't think that you're graphing this particular function because this graph shows a fundamental misunderstanding that this is asymptotic to the x-axis.
I see. Okay, so this
This
one's no
actually
good.
this actually
Like,
goes
I
back
mean,
down if you look at it more
okay. So this
carefully.
is, and it's like this first one was fine. So this is my poor drawing skills.
But
I'm very bad at drawing, is what I guess I'm learning.
right.
But I guess
So, like,
my
yes,
point
I don't
here,
really particularly care necessarily about, the 100% accurate version of this, but
right?
if I were to take this, I'm going to just go down here a little bit. If I were to take this graph and work at it from here, right? I'm going to take a minute to do this, but it's oftentimes it doesn't take students very long, again, once they understand.
Right, right.
So if we just do a simple -5 to 5 graph here,
Right.
right? We know that our origin point has been shifted left by a distance of 3. We're now at -3, 0. There's no vertical shift on this. And the basic function, right, the parent function, y equals 1 over x, either the student will come up with something like this and say, okay, this is going to be like, -3, 1/3, -2, 1/2, -1, 1, and then, -1/2, 2, those are negative. Come up with something, and these are now distances, not 100% accurate points. So the student in this case would say, okay, if I want to just get a graph of this, I know that the distances are going to be, we're going to start at a distance of 1 by 1 to get our initial point, the first location that really shows up and is something that's easy to just grab. From here, the inverse nature of this thing is that I'm going to double my x distance, and that's going to cause me to halve my y distance. From this point, I can also double my x distance and halve my y distance again. And we could do the same thing here. Going in the other direction, we can halve the x distance, and then that causes us to double the y distance. Halve the x distance causes us to double the y distance, etc. So somebody who has been working with, this particular style would be able to graph something, roughly speaking, this accurate within a minute. And that's only the positive side, obviously, but
so what I'm again, I think as I'm looking at what you're asking, if this is what you want students to do.
So I'm not demanding
like
this. If a student comes up with an XY table and plots it, then I'm perfectly happy with that.
Okay, I just want to make sure I'm clear, because I
Yes.
feel like what I'm hearing is that the goal is different. I feel like this goal is saying, I want to realize I'm able to graph variations on 1 over 8. So if I were to see 8, so students will, let me try to write this. Students will graph A over x minus b times c plus d using multiple. I'm trying to. This isn't great, but it's first draft. Using multiple reference points. I think that's what you're getting at with what you're saying here, right?
So, like I said, I'm not requiring this, but I show, or when I'm doing this as a lecture, I show this for the like first stuff that we do way back at the beginning of the course, and then every single time that a new function is brought up, here's the parent function, and if we do a function transformation, here's how that changes. Oh, look, if we just shift it horizontally or vertically, then the distances, the scheme doesn't change at all. And so we can refer back to the distance scheme and bring it to this location. Now, like I said, if the student wants to graph just an XY plot that they get off their calculator, and they have individual points that are at least reasonably accurate, then sure. If they just go, looks like this, then no, I'm not going to give them credit for that, because that's not accurate to a precise Cartesian coordinate system.
Yeah. Right. So I guess if we're doing, I feel like there's two things going on. That's why I'm trying to make sure.
Could be.
I want to make sure that I'm understanding what your goals are. So
Okay.
If we're going back to goal 1 that we wrote before, my goal here is to notice asymptotes and intercepts. My goal at the bottom, if I look at what you're doing on with the points, I'm hearing that this is done beforehand. Is that correct? If I were to sequence these lessons, this one would have come first.
So
and that the second one would be separate, or am I misunderstanding?
I would argue that this lower one is kind of on the way to getting the other. That we would be doing
part of the same lesson. I see.
Probably.
Probably. Okay.
Again, this is community college. I have an hour 20 to an hour 50 for every lesson, depending on which one it is.
No, I get what you're saying.
Yeah.
I get you.
I would be saying, like, this is the reference that we're using according to my particular scheme, right? I decided that all of the functions, this was a common complaint of students that I received, not even my students, back in the first few years that I had become one of the coordinators of this class, in that, pre-calc, and Dr. Gold still says this, pre-calc is this hodgepodge mess of just all the stuff you need to know without having any real cohesion. It's just, here's all the things you need to know. Just, we're putting them in some semblance of order, but
package, yeah, some kind of package.
Right, but he's not fond of it either. And so my initial, my final attempts at cohesion really were, okay, we're going to use this and say, all of the functions that we're talking about can be related to this function transformation model. Then there are more nuanced and more complicated versions.
Okay. So I see what you're saying. If it were me in this situation, and that my goal was to have them use reference points like you have, what I might do is I might
they don't
separate
have to have them.
No, I know.
I'm just saying this is the fast way to do it, honestly.
I get what you're saying. No, I guess we're disagreeing, if at all. I think we actually agree on some things, because I see what you're the reference points you're emphasizing lead to a nice discussion about asymptotes, right? Mm-hmm. That this horizontal asymptote is what I'm approaching in the limit.
Yep.
If I'm being formal for our sake, I don't know that I'd use that right away with students, but ultimately we're talking about limits as we go to infinity and negative infinity, right?
In this particular class, I had used that name in chapter 1.
Okay.
Because I was this was the, I started doing it in all of my classes, but this was intended to be the 1 semester pre-calculus course, which was 5 credit hours, which would cover all of pre-calculus. The rest of our institution had broken it up into functions and trig as 2 separate classes, but 3 credits each. But hey, we can do it in 5.
Yeah. Right. Okay, so I guess, like I said, I'm my inclination is that I would again separate these.
Okay.
That's just my preference. And this is there's multiple implementation options.
Yep.
I think you could probably do this in one lesson. My concern, I'll give a sort of parallel example of where I saw this.
Mm-hmm.
Going back to our sequence example, I took this too far, and I had students calculate really hard numbers, and students were more interested in finding the explicit formula for these sequences
Mm-hmm.
than they were in trying to find the general relationship. And I found that their desire for a formula led to it almost backfired the first time I ran a task like this. It was about series, and they had to find the actual the series value, the sum of the series, not the sum of the sequence.
Uh-huh.
And what I found students doing, especially when I had really hard numbers, was focus on trying to find an explicit formula for the series
Mm-hmm.
rather than try and focus on when the series converged, which was against what my purpose was. Where they were trying to find this nice formula, like this nice closed form thing that would, when I took the limit, it would give me the value of the series. I found that it sort of derailed my lesson.
Okay.
And my thought is, in sort of parallel, I worry that that the design is everything. So that when you design the design of the task needs to focus on, if our goal, for example, is asymptotes and intercepts, the focus needs to be on those things. I think what you're bringing in about having points as a scaffold,
Mm-hmm.
if that helps students, is excellent. Like, that's really good. But I also would put the emphasis, if students didn't have something picture perfect, but that they had the general relationship right. And I think we speak the same language on this, because I was hearing that, yeah, you don't want to focus on all the, you don't have to have all the points, but I worry that the focus is everything, right? Like, where do we put the focus of our time? If I leave the focus where I have these graphs pre-scaffolded and drawn, and they're already drawn correctly to scale, maybe one way to do this is have these benchmark points already put in a graph, so that the students aren't doing the work of graphing at first, but they're
Mm-hmm.
just noticing relationships and saying, "Oh, look, there's this." That's one of the things they could notice is this 1-1, 2-1/2 thing. Maybe that's something you could put in some anchor points in each of these graphs, so that those relationships are emphasized. I don't know. Maybe that would help. Since that I don't know. That's what I'm thinking right now. Is maybe we throw those in. So, for instance, put the right here. This is. Let me actually fix these sketches, because you're now making me somewhat self-conscious of my drawing ability. But just so I get rid of the
I mean,
self-consciousness.
if we just take this one over here, this was fine.
Yeah, but still, I should. I have a PhD in math, and I can do better. That's great. Okay, great, excellent. That's wonderful. Just get rid of that. Yeah, pretend it never happened. but
It's
my
totally how it
point
works.
is that you move over the point. Like, we can put this at -2, 1, right? Did I get that? Yes, I did. Okay, and then we can put this one at 1/1/2, right?
-1.
-1, thank you. And I could put those in just to emphasize the structure, that there's this common structure of distance, right? Like this 1-1 and 2-1/2 distance is consistent among all the different graphs. But that when I come over to this one with a multiple of 2, I can now emphasize that relationship that's different.
Mm-hmm.
So maybe that would build in the thing you're trying to emphasize. Have those pre put in for students, so they have an opportunity to notice the relationships you want them to see.
Mm-hmm.
And then when they make their own, they can have those, that almost trains them and scaffolds for them the need to have anchor points. That would almost encourage them to use that, because then the induction would be designed to transfer. to future graphs.
Right.
Yeah, so put in 6-2, put in whatever the other one will be. 7-1. Yep.
Yep.
Okay, so I think this would make a really interesting sequence of tasks. And then you build in the other parts, right? If you even wanted to take it further, you could have some symmetric points on the negative branch.
True.
If you like. But what your thoughts? I mean, I'm just rambling here. I was trying to listen to what you were saying, and I feel like I get the feeling that having these anchor points, while not required, is important. And so I feel like that's actually not a bad thing to have.
Mm-hmm.
We could just scaffold that into the task.
Yeah,
And that
potentially.
encourages its use later.
Mm-hmm. Or include the anchor points over here,
Mm-hmm.
and then
Yep.
don't label them here,
Yep.
and then leave them off in the last one. So
Right.
the students
Good. Would naturally, yeah, so that they have to think of that's something to think about.
Given
Like, where would those anchor points be? That's something you as the instructor could then scaffold for the student. Say, well, where would the anchor points be? That's reasonable.
Yeah.
Now there's more to do. I claim. I think I'm gonna have to get going because
Yes,
it's 3:00.
absolutely.
While my kids are getting picked up by the missus, I do have some other stuff to work on this afternoon.
Yep.
So I do need to leave at 3. But this has been, I think if you were to extend this task out and continue to develop it, this could turn into something really useful for when you teach a pre-calculus class again.
Yeah.
Having this sequence, the scripted task, could be really helpful.
Well, like I've said, at this point, I don't know if I'm heading back to community college when I get back, or if I'm going to actually attempt at going back to public school, because I'm, much older than the students now instead of 5 years older than the students.
Fair enough.
Or potentially start getting into either admin or educational policy. So
yeah, that would be cool too. I know that's a fun field as well.
Yeah, we're gonna need
it. It's gotten into that, so a little bit.
Yep, and the school board where we were at is in a rather interesting situation. So
yeah, well,
as it is in many places.
I was gonna say it's very, very. I can get behind what you're saying 100%. Well, thank you very much,
right.
Obi. I appreciate you.
Yes.
Thank you
so
for
much,
doing
Zach.
that. I'll probably chill and chat for a little bit and say hi to others as the night goes on, because we've got other streamers going on, and
sounds good.
I'm excited to see what you're going to do next with this, if at all. You can also discard everything I just said.
Not everything.
You can openly roast me after I leave, and I have nothing I can say about it. It's totally fine.
Totally not defending yourself. Woohoo!
Yeah, I can't do anything. I'm defenseless after I exit this call. So anyway, do as you wish with it. But I hope you enjoyed the discussion and it was helpful.
And thank you so much, Zach, for coming on in.
No problem. Glad to see you. And thank you, Matt Laforte.
We'll hang out again.
Matt Laforte and Kaylor, thanks for hanging out. Like I said, I'll be around and I'll be in chat.
Yep. All right. Okay. Thank you so much.
Catch you later.
Yep. Bye.
Bye-bye.
Oh man, that's that guy. All right. If anybody does have any particular questions that you might be interested in, and Matt Laporte, good evening and welcome. Kyler Cohn, thank you so much. Ads are about to start, so take a 3-minute break. get up, stretch, walk around, do all that good stuff, and we shall return in shall return in just about 3 minutes. Thank you so much, everybody, for coming. Thank you, Zach, for coming and being on the discussion. And we'll definitely do it again at some point. We'll see how things go. So, see you all in a little bit. Well, good evening, Matt. Yeah, we're getting there. So, do you have any particular questions about any section about math, how to do things, what might be a good lesson? So my level of mathematics is, well, so my name is Obi-Wan Pez. This is N-Simplex Pachinko. We do mathy stuff on Mondays and Wednesdays. Typically Monday is like a more math education type day. Now that Zach and I have concluded our discussion about building thinking classrooms, I'm going to devote the rest of the time to basically whatever people want. So we can discuss math education, we can discuss mathematical topics. My actual teaching has been everything from basic algebra all the way through differential equations. So that's like, second year undergrad. What level of math have you been learning? If you say it's from the British system, then I have some experience with it, but I haven't taught it. And obviously, I would know how to... Theodoros, good evening and welcome. So typically... most of the math streamers around here don't really do homework explicitly, but I can certainly give you some things to think about on the individual topics. So... if you would like to get some help on it, we do have a shared Discord server for the elements. You're 2.77 out of 20. I am Magic Method 1820.
This week it's Safer Gambling Week. Bet there, we believe in betting at your best. Which is why we've teamed up with Pure Gym to give anyone who uses their profit and loss tool a 3-day gym pass for free. Because our bettors deserve better.
This is probably not the website I wanted. The mathematics curriculum, there we go. Numbers and calculation, geometry, quantities and measures, organization and management of data. Okay. grades 3 to 5. At the end of primary school cycle 3. Oh man. Well, anyway, if you do have a particular question about like a given topic, I would be happy to try to explain it. And like I said, that Discord server there is for The Elements, which is our shared group among all of the math educators in our group. So if you do go there, you can post either in the Maths forum or the Maths chat. And if you go to either of those locations, should be somebody around fairly soon to help you out. If it's while I'm here, there's a good chance that I'll see it and we can discuss. Oh, yeah, it's c'est pas de problème. Je comprends un peu. So, okay. So, you're more interested in the stuff you might find out about just outside of school, which I can understand completely. Hey, thank you for the follow. So, some of the things that we talk about on this particular channel include things like mathematical books. In this case, this is Sunil Singh's Chasing Rabbits. It's all about coming up or finding interesting mathematical problems that just exist out in the world, and then just deciding to work at them. Now, I grant you that this is mostly for educators, so there are other places you can get that fix if you're interested. You don't have to look at this. This is mostly for, like I said, for educators to try and understand what is going on and how we can create more interested students. So, as you can tell, I've found this book rather interesting. And actually, we probably will go over this book. Et juste un peu. Terriblement. Oh, Calicon. Yeah. Yeah, we should definitely go over this book chapter by chapter eventually. However, All right, so one example is from Alex Bellos. And if you don't know Alex, he's done a number of really cool projects to try to help students understand how math works. And he was also doing a weekly math problem, essentially, in The Guardian. And he also came up with a book called The Grapes of Math. Been living in America, and I know that one. Whew. Hey. Punk. What you doing? Nope. Okay. Copy. And we paste. There we go. Right. So if we take this and reverse it. Then wait a minute. Ah. If this is, in fact, a 75 centilitre bottle of, Sunil says whiskey, but, whatever you want, Coca-Cola, what have you. The current amount in this bottle is 14 centimeters from the bottom when the bottle is sitting upright. And when inverted, the amount that is in the bottle covers a height of 19 centimeters. So then the question is, how much has been consumed with that much information? I mean, that's fair. We're talking about whiskey and whatever. Thank you for the hydrate. Yes, is very important. So yeah, if we have now, if you already know how to do this particular question, it is actually fairly nice to work with and interesting to figure out. So I do recommend, if you've never done this before, give it a shot. There was a my trivia league has, this is online. My trivia league has a series of 1 days, which you basically go in and you have 24 hours in which to answer 12 questions. Typically, if you're playing against somebody else, you have like it's a league, and it's set up in the same way as like the football leagues, where you basically play everybody else in your they call them rundles, and then eventually yep, eventually you play everybody and try to figure out who's best overall, best you can. So there was a 1 day where you answer, instead of 6 questions against people, you're answering 12 questions, and then you score 5 of them as the money questions. The goal for the money question is A, you think you have it right, and B, or you're willing to gamble, and B, A, B, right? And B, you think everybody else is not going to get it right, or like as few people as possible. If you end up getting it right, and, well, if you end up getting it right, you get bonus points based on the number of other people who got it wrong. So if you have moneyed a really tough question, then you typically end up getting a lot of points. So for this one, this was actually on a math 1 day that came up recently in the Trivia League. So it was a whole bunch of people ended up getting this particular question wrong, and I got it right because I've been trying to figure out Sunil and Alex's version of this that is in Sunil's book. So I eventually figured it out and was like, oh, what do you know? I got it right. That's okay. So for this particular problem, this is what is called in both Peter Liljedahl and Sunil Singh's books a rich task. So something that is, generally speaking, gets students to think, while at the same time not being particularly difficult. It is something that is accessible to most students. So, I mean, was it the, essentially? I'd like to understand, but STV, I don't know. Combien de whisky à consommer? It's probably terrible. I ate de consommer. That's all right. So if we have the bottle right side up, there's that much. So this is 14 centimeters out of the total 28 centimeter height, and it has a little groove in the bottom that takes out some of the internal space. And then when it's flipped upside down, all of that whiskey here is filling the neck, and therefore it goes up a little bit higher in the total height of the bottle. We have 19 centimeters worth of whiskey if we just take the bottle, turn it upside down, rather than the 14 from the original. The total of the bottle is 75 centiliters, and also it's 7 centimeters across in just diameter, and 27 centimeters tall. So if we take that into consideration, how much of that whiskey has been consumed? Yep. So it's a sealed bottle, not changing anything. All we're doing is we're flipping it upside down. Actually, I can get an example. Okay. Par exemple. Hot sauce. Alright. Ooh. Why is that doing that? Merci beaucoup. Okay. So, do I have... I swear I have another set of calipers somewhere. This one's not cooperating with me. That is my problem. Not so much yours. Ugh. Oh, come on. They might be downstairs in my toolbox. Not the point. I also don't want to waste any more time on this. So, come on. Why is this happening? Oh, yeah, smart. All right, so if we measure this bottle, it is right. So this actual one here. Come on. Is 4.3 centimeters across. The height of the liquid inside of this bottle. Now, I am going to include the bottom of the jar, so oh well. Is about 17 centimeters total. Exactly. Yeah, exactamo. Okay, that is 9.5. Okay, now we have to seal this one up nice and tight. Because I do not want this leaking. Hashtag not sponsored. It's about 14 centimeters. It is, in fact, a bottle of hot sauce. You know what you have to do, don't you, Color? Right, so the issue here is that they are not the same. C'est pas la même chose. Okay, so how do we deal with these two things? They're not the same shape. They're not really, I mean, it's the same size. It's just that the volumes right side up and upside down are not going to be the same. Yeah. C'est un peu difficile. Right, so so premièrement, first thing we can look at is that, well, these things are actually the same. So it doesn't quite cover it in terms of like how much area or how much volume do we have out of this. We're not entirely able to just cancel stuff out or anything like that. It'd be really nice, but unfortunately. There was, however, something that I did do that was identical between them. And now I'm struggling to remember what it was. Okay. It might be. Now it might be. Hmm. Moi. Yeah, I've been told that like my accent is pretty good. Um, I had a Francis Canadian barber who insisted that I practice with her every time I was there. I'm just like, I feel so every time that you ask me to every time that you ask me to practice French with you, I'm just like, but I'm terrible. She was like, no. You need the practice, and quite frankly, she was like, I just really want to hear French. This was in New Hampshire. It's just more interesting. Oh, it's interesting. So for a lot of it, it ends up being like the foundational stuff is going to be very important in order to be able to understand the rest of it. And yeah, the way that it's taught at school is not ideal. Zach and I were just talking about stuff like this before you all got here. Or maybe you were watching some of it. Let's see. Yeah, okay. This was it. So if we were to just draw a rectangle around all of it. I'm pretty sure this ends up needing to be done in this sort of way, right? How much of each section is going to be shaded? So I'm probably doing this wrong, but it's okay. Okay, so if we were to like simplify this, we end up with realistically, right? We did that in white there, so we might as well just leave it in white there.
On January 2nd, over 300 people were seriously ill with flu in our local hospitals. That's the equivalent of 10 full wards.
Okay.
So this winter, our best chance of
So from over here,
quick, simple and free for many people, flu vaccination, especially
we have the same. This is now 14 out of by 4.3
Check your eligibility and find your nearest vaccination
of
center at letsgetvaccinated.co.uk. etothe2ipi.
17 by 4.3.
Quality time spent with catching up on your debt. Business admin cutting into family time. Sounds like you need to supercharge your bookkeeping with Xero. With automated bank feeds, smart reconciliation,
Okay,
and online
and there's
payments,
something we
your
could do
business can
here.
its thing, while you do yours. Supercharge your business and get back to what really matters. Tap the banner to try Xero free for 30 days. Terms apply.
I think it ends up being the ratios end up allowing us to create a common denominator essentially, and then we say like of this particular one we have this much taken, of this one we have this much remaining in terms of an actual sauce or this exact process, almost not at all. However, the point really is to think more broadly about stuff and just think in general. So we end up doing a lot more just thinking about things and discussing and talking about how all of the mathematics works, and it makes it a much more interesting process. I really need to look up the other problem that I had, because that was way easier. I still need to do my trivia. Woohoo! Speaking of, okay, so going back. Ah, pen and paper math. Yep, there we go. Nope, that's not what I wanted. Try again. View questions. Bottle, cylinder. Yep, that one's the one. Alright, take that. Put it into Discord. No, don't do that.
Brace yourself. I can see the end inside. 3, 2, 1. Hardwired.
Alright, let's do the easy one. And then we can reapply this back the other way. that. Whole thing's 12 inches tall. Easy enough. When it's upside down, it's filled to 4 inches. Or, sorry, when it's right side up, it's filled to 4 inches. When it's upside down, it's filled to 6. So then, what fraction of the bottle's volume, including the neck, has been filled? Okay. How did I do it? Because I got it right. So the difference between the two is going to be 2 inches. This is 6 empty inches up top and 4 filled at the bottom. They happen to add up to 12. Well, I mean, never mind. They will, of course, add up to 12. But the difference between them is 2. Okay, so fifths. No. 15 cans. Oh, no. Come on, 30. Jeez. Oi. Oh, man. Alright. Oh, don't I know it. But right now I'm also living in the UK, which is really interesting because we use both miles an hour and kilometers an hour. We use miles and kilometers. We use imperial and metric for drinks. You know, down the pub, they're very happy to use pints, but at the same time, their imperial pints are slightly different than American pints, which are slightly different than 50 centiliter. I think we use 50 centiliter. Yeah. 50 centiliter. They're using them pretty much interchangeably. Okay, so if that's 2/3 filled, and this part up here is 6 units, right? Then that's, the whole thing is, right? So this is going to be 4 out of 10 units. Right, okay. So this is actually a little more complicated because it has the divot on the bottom and also the bottle shape at the top. Top, bottom. So because it has both of those things going on, that is actually a slight issue. But shouldn't be terrible.
Who better to explain how Anadin Extra can speed up pain relief than a professional voiceover man? The one who speed reads the legal stuff. With triple action pain relief, Anadin Extra gets to work in 5 minutes. Simply pay on purchase and nothing later. Subject to all the
Okay.
stuff I normally read out at speed.
So here,
Gets to work in
if we
5
take
minutes.
14 centimeters,
Based on caffeine
it's
absorption.
roughly speaking here.
What if you could send a free chocolate bar in secret to someone special? Just to, you know, give them a little lift. With the Cadbury Secret Santa Postal Service, you can send free chocolates secretly from a poster. They're popping up all over the country. From great big cities to quaint little towns. Look out for a poster near you, or search Cadbury Secret Santa to find out more.
Okay.
18 plus. Free service on selected products while stocks last until 21st December. Visit Cadbury.co.uk for terms and conditions for full T's and C's.
It's the divot that's really bothering me at the moment. So if it was a flat bottom, then it would be 14 by 7. And here, this empty bit will be 8 by 7. So that'd be 56, and then the bottom part would be 19 by 7, but would only be partially filled. Okay, it would be... Okay, would be 14 by 7 is the liquid, plus 8 by 7 is the part up top. So if it were flat, then we'd end up with 14 plus 8 is 22 by 7 is 154. Oy. Righto. So thank you so much. Yeah, merci beaucoup. Venir ici. Et bonne chance. Let's see. It'd be 154 units. 14 by 7 is 49 by 2 is 98. Which is then 49 over 77. Which is 7/11ths. However, that's with a flat bottom. Merci beaucoup. À bientôt. Yeah, what little I do actually speak, I've been told I have a good accent. Okay, so with a flat bottom, we've got 7/11ths. Then we have to consider, like, what about that divot? So, does it, wait a minute, does it just cancel out? Oh, you jerks. That might be the case. Yeah, it does. Okay. That is a similar reaction, by the way, to how my students have reacted in the past. Okay, so if we flip it over, if we move this bit, again, this is going to be up a bit from where it was. Okay, so this part at the bottom that's filled is going to be, just roughly speaking, right? The whole thing is also going around, but we can just say, like, because this is symmetric all the way around, hashtag not sponsored. If the hot sauce people want to sponsor me, what we can say is that, like, this stuff in here is just going to be X square units to talk about the, like, surface area of this thing. Because it's uniformly distributed in a circular region, right, then if we just do this in 2 dimensions, we're going to get the same results as if we were doing it in 3. So it's not going to really matter. And again, what we're doing is we're not looking at strictly how much liquid is in there, but rather what percentage of the liquid is in there compared to the other. So because we're comparing it, it's going to be really great. All right, so this is going to be 14 by 7 minus X. that
especially
bit
if you're
out of the
very
bottom.
pregnant or have a long-term health condition. It can be seriously
When we flip it
dangerous
upside
to get
down,
to.
right,
Check your
the empty bit
eligibility and find your nearest
now
vaccination centre and
contains the divot, right? The empty part contains the divot. So the empty part is going to be 8 by 7, which is going to be 56, minus x, which then gets us, again, that top bit that's empty. So if we flip it upside down, now we've got 14 by 7 minus x plus the top section, which is 8 by 7 minus x. Okay, it doesn't cancel out entirely, but that's actually okay. Because we're not subtracting them, right? Right, so this is going to be 56 minus x. And then this one's going to be 14 by 7 was 98. So the whole thing all together, volume is going to be equal to, sum them up, is going to be 154 minus 2x right, that's the total. And the volume of the liquid is going to be equal to either no, we just have the 1. So 98 minus x. Oh. Volume total is now equal to twice 77 minus x. Yeah. Yeah, that doesn't help as much as I wanted it to. That's fine. Alternatively, if we go the other way, right, this being a two-stage problem, there's probably going to be 2 issues. So here, we call the total here y. And this could be, right, 19 by 7 minus y. (14) from 27 is 13. 13 by 7 minus y. Okay, so now this is 19 by 7 and 13 by 7. Another 2. All right, 91. Or another 42 beyond that is 133. Yep. Okay, so the total volume then has to be 133 minus y. And 13, no, 91 minus y summed together. So that's going to be 224 minus 2y, which is twice 112 minus y. And the volume of the liquid not the sum, is going to be 133 minus y. Alright, so now we have multiple equations that we can work with. Shift around. In the total equations, get rid of the 2's, swap the x's and y's, move the 77 over. That's going to be 4035 plus x is equal to y. And from liquid, same deal. Swap the variables, move the 98 over. We subtract 100, add 2. It's the same equation. Okay, so we got one equation and 2 unknowns. Well, curses. It makes sense because we're comparing the exact same thing in both cases, right? What's the empty space in both of these things? The difference between the empty spaces is 35. Oh my goodness. Okay. Could this be useful? So 410 by 7 is 98. That's 133. So yeah, we get the exact same thing. Ah. Okay. As a percentage, the empty space is going to be 91 minus y over the total, which is going to be twice 112 minus y. So this is V empty over V total. So this is how much is consumed. Which then must be the same for the x equation. Which is going to be 77 minus x over... Nope, that's the total. What did I just do? Okay. Don't do that. Not that one. liquid. Oh, no. That's the liquid. Subtract it. It's 56 minus x is the empty portion. Okay, so with that, the 2's are going to divide out. And this is the one time I'm allowing you to say it. We're allowed to cross multiply.
Who better to explain how Anadin Extra can speed up pain relief than a professional voiceover man? The one who speed reads the legal stuff. With triple action pain relief, Anadin Extra gets to work in 5 minutes. Simply pay on purchase and nothing less.
So 91 minus y multiplied by 77 minus x needs to be equal to 56 minus x times 112 minus y. I really hope that this comes out with something other than y equals 35 plus x. However, I'm not going to be entirely hopeful. So, 91 by 77 minus 91x minus 77y plus xy is equal to... Yeah, it totally is, isn't it? 56 by 112 minus 112x minus 56y plus xy. Okay, so easy enough. XY's are going to go away. 91 by 77 might be bigger than 56 by 112. Not by a huge margin. We'll see. Alright, 91 by 77 is going to be 6,300, 630, 70, and 7. So 7,007. Nice. And then we can move x's this way and y's that way. So plus 112x plus 112x. Okay, this is going to be 56 by 112. Right. 5,600 plus 560 plus twice that amount is 112. So this is going to be 61, 62, 72. Okay, 77 minus 56 is going to be 21. Equal to, subtract 62, 72 from both sides. And then this is 112 minus 91, which is going to be 21. Oops. Okay. Ah, shit. Yep. What do you want to bet that that is a multiple of 35? Probably 21 by 35. Alright, so that's going to be 900. 735. Yeah. I was so hopeful. Y equals 35 plus X. Yep. Cool, cool, cool. Okay. Let's see. There's got to be an easier way to do it, right? Right, I really don't think that trying to do the opposite one is going to help any. I think it's going to end up with the same stuff, but hey, why not?
On January 2nd, over 300 people were seriously ill with flu in our local hospitals. That's the equivalent of 10 full wards. So this winter, our best chance of staying well is by getting a quick, simple and free for many people flu vaccination. Especially if you're older, pregnant or have a long-term health condition. Children can be super spreaders, so get them vaccinated too. Check your eligibility and find your nearest vaccination centre at letsgetvaccinated.co.uk.
I mean, in theory, right? You should... Oh, that'd be terrible. Never mind. I was going to say, you should be able to swap the denominators at this point because both of the totals represent the exact same quantities. But yeah, that'd be terrible because when you cross multiply, you get x squareds and y squareds. So, yeah, that would not work very well. Well, that's too bad. Anybody have any other questions while we're here? I mean, like, he didn't give any measurements on that, I'm pretty sure. Yeah, no. I mean, it's very intentional, right? You give as little information as possible to be able to solve it. Okay. I think if that is all we're going to get for the night, then we might head out and... Hello. Dr. Gold is up. There is also somebody here called etothe2ipi. I have no experience with this person, but we might roll the dice on this one, given that we only have a few people in tonight. Yeah, so let's give a shout out to Dr. Gold. Underscore. Oops, nope. Ignore previous message. Yeah, you could tell it's wrong because it echoed my channel. There we go. So, go check out Dr. Gold. He also does SAT and other math prep sort of streams, and we'll roll the dice on etothe2ipi and see what we got over here. So, looks like the Euclidean algorithm, GCDs. Yeah, we'll give it a shot. Can't rate. So, go check them out at some point. I will add that onto a new tab, and maybe we'll head over there in that secondary tab. Okay. So, Dr. Gold. We'll go ahead on over there, and I hope you all have a good evening. We're going to be coming back tomorrow for more 9 Souls, and absolutely torturing ourselves on trying to figure out the next area and do more unbounded counters. There we go. Unbounded counters. We'll see how it goes. So, come on back for game stuff tomorrow. Come on back for mathy stuff on Wednesday, where we will look more at cracking the GRE, and if anybody else has any particular questions, we'll also do some of that stuff. So, good luck, everybody. My name is Obi-Wan Pez. This is N Simplex Pachinko. We'll catch you next time.